Ideally, your electricity flows from your service panel with all of your breakers or fuses throughout your house to power your appliances, your outlets, charger devices, and so on. Sometimes it doesn't always work that way, and you need tools to be able to troubleshoot. Tools like this multimeter. As the name implies, a multimeter is a measuring device that measures multiple things, such as voltage, like the high AC voltage that's going to all of your switches, outlets, and appliances. DC voltage, which is useful for measuring batteries, see if they have enough juice in them, or if the batteries have gone bad, and other various DC electronics. There are low voltage areas in your house, such as your outdoor lighting. You might have lighting on your lawn, your thermostat, and doorbells have lower voltage than 120 volts in North America. Also, even things like resistance and using continuity tests to make sure something has a complete circuit, such as the coil in your electric dryer, which you may use the resistance setting to see if that is still working. And something like this multimeter will have various other functions, as a handy light, non-contact voltage tester, and even tests things like frequency and temperature, which can be handy. So in this video, I'm going to show you how you can use a multimeter around your house to troubleshoot your electrical issues. You may be uncomfortable poking things into an outlet. Really, what you're doing is you're just touching the conductor with an insulated instrument, but that's understandable. What you can do is take this off, take the cover off, and all of that metal should be grounded. Ground screw will be green. There should be a copper conductor on it. If you have aluminum, then that's a problem. You should probably get that changed. But you should see a copper colored. And then you see a silver colored terminal. That's a screw that's holding that on, and that's the neutral, the larger prong. The smaller prong is the hot. And if you can barely see that, that's a brass colored screw. And to test to see if you have voltage going through, you can take the probe, touch the brass side, and then you can touch the ground. 120 volts should go straight from the hot back to the service panel through the ground. If it's not grounded, if you touch the grounded screw, then that won't happen. You can still take the black terminal and go to the neutral terminal, the black probe. So that tells me there's 120 volts coming through here, and it is grounded. One of the places where you would have a lower voltage in your house would be a thermostat. Most thermostats would have about 24 volts AC going to it. On this multimeter, we set the voltage, set the knob to AC voltage, and then hit the function button to go from hertz, from DC to AC, or to hertz. In this case, I want AC. Alternating current is coming to this, 24 volts. What it is, it's 120 volts that's being stepped down at a transformer downstairs. So you can measure that with the leads to see if you have power coming to it with the leads. As you can see, a little under 20 volts. It can be a little bit more difficult to measure the lower voltages because a non-contact voltage tester may not read it as live at all, even though there is 24 volts, or in this case about 20 volts coming into it. Another place could be a doorbell, which would not be 120 volts. It would have a transformer such as this one, and it'll usually be found around your service panel. I have the breaker box right here, the service panel, and then a wire would go up, and then small bell wire, very 18 gauge or so bell wire will go from that 16 volt transformer. What a transformer does is it transforms down. It's kind of out of the scope of this video to explain that, but it takes 120 volts, has coils in there, smaller coil on the other side, so it's smaller voltage, and then they get really hot, physically hot to the touch, and then the power, the voltage will then go to your doorbell. A smart doorbell, which many of you probably have, may need up to 24 volts. Another really handy feature of this Tesmen TMM-569A is it has a non-contact voltage tester built into it. So you don't need a separate instrument to find out if a wire is live without touching it. In other words, you do not need your leads to touch anything to find out. In this case, I set it to NCV, or non-contact voltage test, and then that can actually function through the different settings as well. But here it is a non-contact. So if I have a wire I suspect is hot, take that part up there, bring it close to it, and of course a beep means that that wire is hot. And like I said, that's for 120 volts. Something like this may not beep for the smaller voltages, but it will for a 120 volt wire. This multimeter should actually test if there is low voltage or high voltage, high being 120 volts, because if you get close to it, you'll see an L for low, and it beeps slower. And as you can see, the H is for high voltage when it gets closer to it. And use something like a non-contact voltage tester to test a strand of Christmas lights or an extension cord going outside to one if the lights are out. Obviously these are on, so these would beep, reading low until it gets closer to it, and then it reads high voltage. But if you had problems with the bulbs, it's possible that the power goes past them. Modern Christmas lights have a shunting mechanism that will send power past the bulb. In the old style, if one bulb is out, then there won't be enough current going through, as you can see, to light the light bulbs. And it's wired such that there's about 50 or so bulbs in each strand, even though it looks like one long strand. So the rest of it can actually work. And in this case, you can see the power is still going through it. It's just not sending current through the lights because one light bulb is missing. In this case, this bulb is missing. It's easy to find a bulb missing, but you might find one that is loose, and that's a problem. In that case, you just have to test each one. Just make sure each one is in the socket. You might have to just try to replace a few at a time, put that back in. So you might have to take a look at the bulb, see if they're burnt out. You can sometimes see a little bit of carbon on the inside if they actually burnt out, but sometimes you see them, they're cracked. The missing ones are obviously the easiest. You might find the glass broken, but the little piece is still in it. You still have to take that out and replace it. But yeah, so just another way that a non-contact voltage tester can test that. Test for, see if there's power going through any wire, including a Christmas strand. I showed the video on the multimeter on how to use it to troubleshoot some of your wiring around Christmas time and checking your wires and bulbs. People asked me if I could show some other things you could do with the multimeter around the house. And it is true, you can use the multimeter around the house. A multimeter is, as it sounds, a meter that has several functions. It's a voltmeter, it's an amp meter. It measures resistance. You can use an analog one, or you can get a digital one that has a lot of different functions and features. Comes with a pretty large user manual with a bunch of different languages. Handy little AAA batteries. Comes with a nice case. I actually like that it comes with AAA batteries because it's a little more common than having a bunch of 9 volts around. And the battery is nice because it can hold it up on your table. Nice little stand. That is something that I have not. That goes into the COM or common. And then the red one depends on what you're measuring. You can put it in a 10 amp if you're measuring high currents. Otherwise, if you're measuring AC voltage or DC voltage, up to 750 volts AC and 1000 volts DC. Most houses will be either 120 or 240. 120 if you live in North America, which means there's on one circuit, unless you're talking about a appliance like a water heater or a
dryer, then you'll have a circuit that sends 120 volts to the load and then goes back through the neutral. When it goes through something like a light bulb, it'll send the voltage through the bottom, and the outside will be the neutral. So power goes through the bulb from the bottom of this and then goes out back through the outside. And you'll notice on bulb sockets, you'll see at the bottom, that is actually where the voltage is coming from. And then the outside here should be, unless it's wired backwards, the neutral. That should always be the neutral or the ground on the outside. This is some kind of antique bulb. Looks like it's patented in 1907, but since then, over 100 years, this hasn't changed much. Your house will likely have the same. This is from a Christmas tree light. Now, of course, you might be thinking, why would you measure a bulb if it's burnt out? You won't see the light. Well, that may be true, but if you're wondering what is wrong with the bulb, you can always test it. And these come out. These are handy. I'm going to be careful with these. I sliced myself up pretty deep with this one time, so it's good to have these things right here. But if you're measuring into something like an outlet, these are insulated. Okay, so it's insulated up to 1,000 volts, and you would just put it in. For example, if this was wired onto the wall, then you could measure with the black here and here on the gold to see the voltage. And you have many different settings here. So you would do look at the manual to see what are these knob settings, what these knob settings do. But if you know the little symbols, then that right there is AC voltage, and this is DC voltage, the line with the little dots on the bottom of it. Okay, but you might be measuring resistance, in which case you'll go to the ohms. Right now it's OL, that means it's infinitely resistant. There is no circuit going through. If you were to measure something like a light bulb, like I said, you have to know where the power is going in and where it's going out, and you put the black on where it's going out. Okay, kind of hard to see the numbers there, but and then you put this at the bottom, and you have about 80 ohms of resistance. And that's about right. If this were burnt out, it would remain OL because it's no circuit. Even though it's a very tiny wire right in there, there is a continuous circuit, and that's where the power goes through, and because of that resistance it lights up, and that becomes the light. So that's resistance. Similarly, in the Christmas light video, you'll see on the bottom of your Christmas light strand, so here you have a strand of Christmas lights, and you will have a fuse inside there, and if that fuse gets blown, then that means, just like that, the infinite resistance, there is no circuit, there's no power going through, and it will not work. So what you have to do is it's like this little door. If you can see that there's a little door, and you take something like a screwdriver and just pop it open. It's got these little tabs in there, and then inside there, because there's two strands, and that's why you might see one strand lit and one strand not, because one of these might be popped. And then you can kind of just pry it out like that. It's got this little metal metal thing holding it together. This fuse allows a certain amount of current to flow through it. Fuses are rated similar to an automobile fuse. This particular one allows 3 amps to go through it. If any more current goes through it, it blows, and then it doesn't allow any more current to go. It's a safety feature, similar with lights. And what can happen with lights is you get a kind of power surge, blows through too much current through it at once, and then the fuse will blow. So this should not say OL, it should say close to 0. Yeah. So that 2 or 3 ohms of resistance, that's about right. Of course, across the path there. That's about right. If this was blown, it would still say OL, or infinite. We have a little infinity symbol. You can also test with a continuity tester. It's pretty much the same kind of test that I just did with the resistance. And if there is a small amount of resistance, but a current is able to flow, then it should beep. If it doesn't beep, it'll stay at OL, and then you don't have a continuous circuit. In this case, the fuse will be blown if it doesn't beep. And there you go. And you even got the green light on this particular one for good measure. Most Christmas lights will have a fuse with it. If you can see, it'll come with a little bag, usually of extra bulbs. These are the old incandescent style. But even the LEDs burn out, especially if there's too much current going through them. And then what you can do, if you're testing your fuse and it's blown, then you just replace it. Once you replace it, then power can flow through like normal again. Pops in as long as it's got the metal on one side and then on the other side. And then you can just shut the door, and then that light, that Christmas strand, should light up. These multimeters also measure DC, which you don't have much of in a house from a home improvement point of view. But you may run into it. For example, this little Christmas strand. This is DC current, direct current. Power flows in one way and comes back in the other way without alternating like in the house power, which is mostly 120 volts going back and forth in America 60 times a second. Like I said, you're usually measuring about 120 volts AC. So here you would measure AC power. There will be AC power coming in out of here. Same thing with a switch. Switch is easy. Obviously, if you're switching something on and you think that there is power going through, all a switch is a single hot wire that gets broken, and then the circuit gets completed when the switch is on. And if you're measuring from here to here, or from here to ground, doesn't really matter which side, it'll just show negative, but from here to ground, if that shows 120 volts and the switch still doesn't turn it on, then the switch is broken. If it's not going, if hot's not going from here to here, basically. If it's going from here to ground, but it's not being turned on, and the switch is just broken. But these multimeters are also digital. They're also DC volts. So this is now measuring DC volts. Here we have power. You know how many volts it should be. Each one of these is 1.5 volts. So this should be 3 volts. Easy way to remember. So you have something with 4 of these batteries, that's 6 volts. Doesn't matter if it's AA, AAA, D, or C batteries. they all have 1.5 volts, even those little coin batteries at 1.5 volts. This one is an interesting case for troubleshooting Christmas lights, because about half of it doesn't light up. And I noticed that sometimes it does. So what could be happening is inside here, even if you see the insulation is fine, there's tiny little wires. If they get bent like this back and forth, inside there, it could break. And the reason you see the lights come on some of the time is because it is making a connection and then it's not. So I think I just ruined it. So see that? See, I can get power sometimes. That's a connection issue. There's nothing wrong with the LEDs. But if you do have an LED strand, they should still come with extra LEDs. If an LED blows, it should have, with modern ones, a shunt mechanism that bypasses the power so it doesn't turn anything off. But this particular one, I don't have any replacements for. It looks like this one might be burnt out. One of the ways the DC voltage tester can help around the house is to test batteries and see if they're still good. On this particular multimeter, that V stands for voltage for either AC or DC. It's got the sine wave, the curved line for the AC, and that line which usually has a dotted line under it for the AC voltage. So we set it to DC, make sure it says DC on it. And here we have a 9-volt battery that should read 9 volts. And it's 7.83, so that's a bad battery. All of these are 1.5 volts. The D, C, they're larger because they can hold more capacity and will last longer. This one is a rechargeable one. It's supposed to be 1.5 volts. And this particular one is supposed to be 3 volts. The little coin cell ones. And it says 3, so that's good. And you can just put like a battery on its side, 1.59, so that's a good battery. We have a C battery here, 1.58. That's good. And then we have a rechargeable one here. And the rechargeable one is only 7.2, so that's only about half charged. This needs to be charged again. That's a bad battery. This multimeter also tests capacitance. It's kind of out of the scope of this video, but it tests to see if these still have as much microfarads. Like this is 220 microfarads. You may find a capacitor in your house, in your compressor unit, in your AC, in your HVAC. That's the unit outside that has the fan. And that capacitor goes bad and you will need to change it. You can test it with the capacitance setting right there. The resistance, which is what that ohm symbol is, but also the capacitance, which is what that symbol is, symbol for a capacitor. So there's resistance, and there's microfarads. So what it does is it sends a small voltage through it. With these electrolytic ones, they have a line that's the negative side. So you would use the black probe for that side. And it tests for the capacitance. 4.5, so that's perfect. This is a 4.7. So now let's test this one. It should say something around 220. And these were all discharged. You have to make sure that there's no power going through it and it's discharged. For small ones, like small ceramic ones, you can just kind of short it out with a screwdriver, these little ceramic ones. And these, it's best to take like a resistor and short it out safely if you're going to be sorting something out, make sure it has a insulated handle, especially the larger capacitors. You will probably not need to worry about little capacitors in the home, but there are capacitors in your compressor unit outside, and they will go bad, and you don't want to have a tech come out and say you need a whole new system. What you do is you would test that capacitor, and if it's bad, then you can replace it. So let's see. Sending power through it takes a few seconds. 208, so that's not bad. So that's 220 microfarads. What these things do is kind of beyond the scope of this video, but that is a something to test. One other thing is that this one tests is temperature. So it has the temperature probes here, go into common input just like usual. And this is either Celsius or Fahrenheit. So this is testing room temperature right now. Kind of a warm day today. Don't have the heat cranked up. 63 degrees. And then test this to make sure I'm not a zombie or a vampire. And close enough. But that's just one other thing that you can do with something like this multimeter testing. Other things you can do that I didn't get into are the phase and frequency, where you can test the power supply to see that you're getting 60 hertz, or any other thing that you would want to test for the frequency. Also current. Current is measured in amps, that's the A. So you can see how much a current is drawn.